Hello everybody. So thank you for joining us today, and good morning from the folks that are in India. I know it's an early Saturday morning, so I appreciate you guys joining us as well. So welcome to the fourth and final installment of the Azure Databricks for Cloud Professional series. Today, we'll be discussing building streaming data pipelines using Azure Databricks and Azure Data Factories. So before we dive into the presentation, a quick introduction about myself. So my name is Wilson Mock. I have over 20 years of experience in IT. I started as a software developer prior moving into the data space. So I worked as a manager of data engineering at Avanade, where my focus was to help customer and clients to create, design, and implement a data strategy to transform decision making. Before that, I was working at CAE as a lead data architect, as well as at Air Canada as a lead AI architect, where we produce various data and AI products to help with the operations. And if you would like to follow me, I can be found on LinkedIn and GitHub at /wilson.mock. Now, for this presentation, we'll be focusing on two topics today. The first topic will discuss designing streaming pipeline using Azure Databricks and Azure Data Factory. That will be primarily be using structured streaming as well as autoloader. If you're not familiar with those names, that's okay. We'll go over them in depth in the presentation and the demo as well. In the second part of this sessions, we'll do a quick introduction on a new feature in Databricks called Delta Live Table. So we'll do a quick demo around that as well. So give you guys a good introduction on that product as well. So at the end of the sessions, you'll be able to design and build your own streaming data pipeline using Azure Databricks and Azure Data Factory. So the knowledge level here is, having a basic level of understanding of Azure Databricks, more specifically with PySpark and SQL would be helpful, and as well as Azure Data Factory. So all the code that you see in a little bit here will be all also available in the GitHub repository as well. And there will be two demo sessions in this call. The first demo will, after the first demo, there will be a 5 minute Q&A sessions, followed by a longer Q&A sessions at the end of the presentation. So so with this, we'll jump into kind of recapping on this journey so far. As I alluded at the beginning of the presentation, this is the final installment of our journey here. So I want to give a recap about the three other sessions that we have. So the first sessions we have, we talked about getting started with Databricks. So this is where we discuss about learning how Spark works, and as well as how the general Azure Databricks are work in general. In the second session, we talked about building our first data pipeline using Databricks and Azure Data Factory. And then in our last presentation, which is the middle of the screen you see here, we learned to build a lake house using the medallion architecture, the bronze, silver, gold structure that we have. So I highly recommend you watch some of the previous videos to get a deeper understanding of our topics today. Okay, and I will also paste the link into the chat here for everybody to have a good reference of it as well. Okay. Excuse me. So with that, let's dive into our presentation. So in our last presentation, we developed this amazing solution for our business, which helped them capture the power usage of the system that they have. So we'll quickly do a recap here about the solution, and then we'll dive into the problem that we're facing and the solution that we want to build. So the power station that we have in our company is sending the utilization data to our Azure storage accounts every 15 minutes. So they're sending the data in there as a JSON file. They're sending this data throughout the day into our storage account. So, in the last solution, we switch over to the medallion architecture, where we take those data that come into our in our storage accounts, and we appended them into moving them in. Yeah, that's okay. We'll continue from here on. No worries. So yeah, just as we talked about earlier, at the top here, this is our power station. So where we send the usage data to the storage accounts every 15 minutes. So those are the JSON files that we compile throughout the day. And through the medallion architecture, we would load all of this new data into the bronze layer the way they arrive. And then through the processing, the next step is to actually apply the business rule, data quality checks, and various other validations from the bronze data before we write that data out into the silver. And then finally, after the silver data is being cleaned, we will then reorganize or restructure the data using a dimensional model technique, which generates a daemon fact table and store it at the goal layer as our curated layer. At that point, we would we build a quick Power BI report and have the Power BI connect to the goal layer through the use of the Databricks SQL warehouse, where we can refresh the reports that they see, and potentially in other project within the organization, there might be other reports that are utilizing and leveraging this power station data. So now, with this success, the business team is very happy with our initial rollout of the set of power stations for the power consumption report. They can see the performance of those each of the stations and the power meters every day, every morning when they arrive in the morning. So they're very satisfied with that. But with that satisfaction, the business now wants to add more power station to the solution, as they're happy with the result. So when they do that, it would actually lead to significant, due to the number of power station, it will lead to a significant increase of data that's for us to process, and that will result in a higher demand for the compute resources, and more importantly, the time that it takes to process the data. So our process is need to start at the midnight, essentially. That's the last data that will be arrived at our system for the day, and then we need to complete this data by 4 a.m. So the added data, due to the volume of it, will pushes our processing time past the 4 a.m. schedule, and this is a potential issue for us, as we won't be able to produce the data for the business in time if we run too far out from the initial set schedule. Additionally, one other issue that we could have is if we only have one shot to really process this data. What I mean by that, if there's any failure in the process, now we definitely will not be able to get the data to the business first thing in the morning, which is a concern for our business team. So we're tasked here to optimize our process from the solution that we build, and we need to make sure we can get the business the data that they need as best we could here. So to optimize this process, there's really two primary things we can do. The first thing is we can spread out the processing throughout the day. So instead of processing everything by midnight, we want to start processing the data in small increments throughout the day. And the second thing is, in order to process this data efficiently, instead of we can break the small intervals of data even in smaller chunks or smaller batches, so that the data can be quickly being processed. The smaller the data set, it is, the quicker Spark or Databricks can handle that data efficiently. Okay, so this small batch curation of the data, it's what we will need to do as part of inside our structured streaming or structured streaming itself. So let's take a deeper look into what that really means. What is structured streaming? So here you see a conveyor belt that we have. So and structured streaming kind of can use a very some easy way to explain this to a conveyor belt system. So in this conveyor system, we have a machine that put the boxes onto the conveyor belt, and each boxes um, what's going through the machine will be repackaged into smaller packages, like what you see on the right here. So with structure streaming, what it does is it tells the conveyor, number one, how many boxes this conveyor belt can take. So in this case, we can take maximum of 5 boxes onto the conveyor belt. Anything more than that, the machine will be broken down. The second thing you can do is, as the boxes are getting processed, structure streaming will keep track of which boxes has been processed. Through the barcode scanner, for example, here on the bottom right hand side of each of the big box. And if we need to restart this conveyor system for whatever reason, the system is smart enough that to ignore boxes that we have already been processed, because we keep track of a list of all the boxes that we process already. So the third thing is we can define a custom process on what data we how we repackage just the data up into smaller chunks. So for example, if in the big box there is some items in there that are broken, perhaps they are in odd shape that we're not expecting it, or doesn't meet our specifications, they will be essentially ignored or put into the does not meet requirement bucket, I guess, if you will. And finally, the machine also, has the capability to figure out which boxes should go onto this conveyor belt. So in this case, we only want the yellow taped boxes from our storage, and ignore all the blue ones, right? So, and this particular piece where we take the data from the storage, from the warehouse storage, and put it onto the conveyor belt, it's a feature called autoloader in Databricks, and will be a little more in the demo. We'll go into more in depth as to how capability works or that feature works. Okay, and then finally, we want more than one machine running, right? So we need to run multiple machines at the same time in parallel, so that the machine can process efficiently our data. So we don't just depend on one machine to run the processing here. So with that, we would dive into our demo here, where we can create our first data pipeline using structured streaming with autoloader. So something that we touched on earlier in the presentation is the medallion architecture. So with even with structured streaming, we'll be following the medallion architecture, where in this case there's 3 sets of different machines. So one machine will handle the bronze pipeline. As we discussed earlier, this is the machine where utilizes the autoloader on the top left, where it only grabs the JSON file that we need to process. Let's say the yellow color boxes, the yellow taped boxes, and structured streaming would then take this data onto the conveyor belt, all the yellow ones only, and then repackage them. Now, after doing that, in the silver pipeline, we would do something very similar. We would take the bronze data, that's outcome of the first pipeline, and we'll apply the data quality check and business rule checks that we discussed previously, and then we write that data out into the silver. And this cycle kind of repeats itself for the gold as well, except that will be done through dimensional modeling as a fact table in our case. And structured streaming will generate the final output for the reporting purposes. Okay. So with that, we'll jump over to the demo. Okay. So this is the the Databricks environment here. Looks like we're having a little bit of issue with the cluster. Okay, it just came up. Perfect. So we have already pre-created a cluster before the presentation. This is the same cluster that we've been using quite a bit. And I'll just click run all here while we're stepping through the code, as some portion of the code might take a little longer to run. Okay, so I'll step through this code more in depth here as this is the first time we're seeing this. So if you have attended the previous session, this code looks a little bit different than before, and that's because we switch over to a Databricks environment that's with Unity Catalog enabled. And what that really means is the security about how we set up our connection to the storage has really just changed. And here's a link in the documentation where you can follow to set that up. The setup is relatively straightforward. Okay. And then the next block here, command 2, the code here is relatively the same. We're just creating the parameters for this streaming pipeline to use. So we're passing in the data lake name, the environment that we're on, in this case is just development, and then the pipeline run ID. And this usually is the ID that we pass in from Azure Data Factory's pipeline run ID. And one thing you might note is that we actually don't pass in the date folder anymore, or the path as one of the parameter anymore. That's because when we're dealing with autoloader and structured streaming, like we talked about, it tracks the files that has been processed, so we don't need to pass that date in anymore. Okay. So for command number 3, this is just setting up all the variables that we need, right? So this data is going to land in the bronze layer. So I define the zone for this data. And in bronze, as we discussed before, it organizes by the data is being stored, and the structure, the tables and the schema and all the file structure is being stored by the source system name. So in this case, our system is the application that we have, which I call it the IoT Smart Grid, and then the data set name is power consumption. That's the data that we have. Again, here, this is just all the JSON file that's being landed. So this is the landing location. That's where the file is, and the bronze location is where the file would end up to be. For the bronze layer, we also will not be setting up a schema for that data. We'll use the infer schema. And the reason is we want schema, if there happen to ever a schema changes that takes place, we want to able to capture that and process that instead of making the bronze fail. We want to incorporate any changes that are coming in from landing as possible, as we would do schema enforcement in the silver layer and above. The checkpoint here, this is a new item added as well. And the primary objective of the checkpoint is to store all the file that's being processed, or the step 2 that you saw in the conveyor belt there. And then finally, the command at the bottom here is primarily just defining the table schema and the catalog name for the database that we're going to be using. Okay. Command 4, if you want to reset this demo, then you uncomment the code and just run this as part of including the above command, and you will delete all the files and drop the database table that you need for this to run correctly. Now, the next command that we ran here is mainly for us to kind of get an insight of the data, right? At the beginning, a lot of time when we're building this data pipeline, we need to be able to do some data analysis at the beginning. So here, I just read the data in like you would normally in a batch job. And I want to take a look at the schema as well as display 10 rows of data that we have. So the first thing that catches my eye in the schema is our date field, the measurement date is actually a string, which is interesting because I expected that to be a date, and we can see that in our data set that this is actually has a date and a time value in there. This is for the most part, this is completely fine in the bronze layer, as we will correct that in the silver layer as we process that data into silver. Okay, so the next step here, we'll utilize the autoloader to grab the file from our storage accounts. We define above that where the storage landing location is. So in this configuration, basically it's saying that we'll use the autoloader, which is the cloud file, is the format that we use. And the file format that we are reading in this case, is the JSON file that we talked about. Now, for the demo purposes, I set the maximum file that I will read per per batch is 75 files. Potentially in your production workload or for your actual project, most likely you'll be reading the number of the size of the contents that you have in megabytes or in gigabytes that you have, instead of reading the number of files. As that would be more better way to quantify the volume of data you have. Okay, and we talked about being invert the column type, and we set that to true. So we'll let autoloader to figure out what the type we have, which is pretty much what we saw just above there. Okay, so at this point, when we run the landing stream, this is very different than loading the data into a data frame like the example that we have. You see the naming convention here, demo df, and I call this landing stream. And the reason is this is a stream of data. It's not the same as a data frame. It doesn't have the same functions that you have normally. There's some functions that are shared. For example, you can run display on it, as an example. Now, just be very careful with running display on a stream, because when you run display on a stream, you would actually your notebook will not will continuously running. It will not end like we have in here. So if at all possible, do not put display in your notebook, and if you do, make sure you remove it after testing, as that would be not good for your programming, your processes, as it won't stop your pipeline, even though if there's no data coming in. Okay. Now, just like what we had for the batch before in command 7, all we're doing here is attaching some of the metadata information or debugging information that we need. So, we talked about the pipeline ID that we should be adding in here. We want to know when this data is being processed. Since this data comes from a file, we want to know the file name, and as well as the modification date of this, when this file was created. And those you can get using the underscore metadata field. That's automatically attached to your job, and that's the same field that we use in batch as well as for streaming. There's no changes there. Now, finally, with all of that set up, we can take our bronze data and write that out into the stream. So the new data stream, which is including all the new columns here, is being written out as a stream with the format as delta, and the trigger is available now. And that is what creates the small batches or the micro batches that we set up above the 75, and that would basically tell it to process all the available data that is coming through. We talked about the checkpoint location. So as we write the stream out, we want to make sure that we specify a checkpoint location so that we know all the files that we read from the landing. And we write it out always in the layer that above the data that you're reading from. So since we're reading from landing, this checkpoint is stored in bronze. When you're reading this data from bronze and processing in silver, your checkpoint that you store for your what data has been read in bronze will be stored in silver instead. And we'll go over that when we go over to the silver code in a second here. As we talked about before, we do merging schema as well. So if there's changes in schema, we want to merge them. We're appending the data only. We're not dropping any data. We're not doing any changes with the data other than adding the columns that we have. So we're keeping all the records that we need in the bronze layer as possible. Okay. So with the start function, by passing in the bronze location, this stream will start read the landing folder and start writing the data out into this bronze location. So as this data is writing, I cannot quite ready to create my table yet because the file has to be created, has to be processed. It takes some time. So as you saw here, it takes about 45 seconds for this batch of data to be processed. So in order for us to ensure that all the data is processed before we create the table, we put a command, we use the command called await termination. So all that does is saying, wait until this whole process finish before you move on to the next block. Okay. So command line is very similar to above. All we really, in the batch processing that we did in the last demo, except that we allow to create something called a catalog now. So it's just a database. If you think of it that way, you can create a database. You grant the database to the demo team. You make sure the demo team is also the owner, and then you create a schema and then the table, which is the external table because we're referencing a bronze location for the data that we written in. Okay. Now, as we just ran that, it took about 3.4 seconds, which is pretty quick. And then the next thing we want to do, and this is normally, you probably don't want to do this in your streaming code or any production code, is doing some data checking. So just for the demo purposes, we would take a look what the data has looked like after we ran through this data into bronze. Okay, so we go look at the dev bronze schema catalog in the IoT smart grid schema, the power consumption data that we just rolled down to. So as you can see, there's a measurement date. Again, if we make this expand the schema here, the measurement date is still a string. That's exactly what we expect. The kilowatts is in double, and so on and so on. But what you will see is actually a new column got added here called rescue data. And this is the same column that was added as when we did the batch pipeline. Basically, if anything that our schema merge would fail, for example, all of the entry here will be null, and then the rescue data will contain the actual JSON output itself. This gives the people ability to rectify any data issues that they have without losing that record. So we would know quickly that given all of the key values are empty, the rescue data must have the actual data itself. And then the remaining three columns are the four columns are the data that we talked about earlier. We added the processing date and we denote all the metadata information as underscore. So the processing date, this is the file name that we have, and then this is the modification date that we have. Okay. So with this data set, there's only about just under 52,000 records here as for our demo purposes. So I just did a quick count to make sure what I expect is what I got on the output here. Now, Technically, at this point, this notebook really has done its job. We ran through everything. We rolled the data we appended the data from landing into bronze. Technically, we're done. Now we've got some housekeeping stuff to do for our streaming pipeline. So in this case, what we're trying to do is we are trying to see the number of version of data got created. And since we bucket each of the file reading to 75 files per batch, we end up with 6 batches of, because we have about 432 files, we end up with 6 batches of data. So if you kind of done the math there, it will be about six batches. And as you can see here, there's 6 versions there. There's range of 0 to 5. So they're all kind of was written kind of right now. So as the number of versions pile up, the Databricks and the Delta format were actually starting to see degradation of performance. So what we actually need to do is apply maintenance on that table. And what this really does is you remove some of the older version number and not allow you to be able to revert to those versions essentially. Because right now, at this point, I can revert to any version of the record that we have, but you really don't want to have run into thousands of versions of your data. You really need to ensure that you reduce the amount of rollback that you can do. And usually by default, that's 7 days that you have. So this is what they call optimize and vacuum. Optimize, basically they try to optimize the number of files that you have in the data lake for this data set. And vacuum basically says you are not allowed to roll back to the old version. Any of the data that you have updated or will remove will no longer be reversible at that point. Okay, so after you run the vacuum and the vacuum process, you would have added 2 additional version onto your Delta versioning. So as you can see here, at version 6, we start doing the vacuum, and at version 7, the vacuum ends. So this basically indicated that the last data or the everything number 5 is kind of has all the data that we have. Any data that updates, it's all consolidated as part of into 7, and we won't be able to roll back to any of the previous versions. Okay, so that's a quick stepping through of the code for the bronze layer. Just want to point out that there's quite a bit of a code that's needed there, because we're utilizing quite a bit of the few advanced feature like auto loading and streaming there, and as well as cleaning up the data that we have. Okay, so the next we have is we'll jump over to the silver file, and I'll point out, I'll stop at where things are different than what we have done in the when we brought in the data in bronze, and I'll skip over the part that are or just quickly talk over the part that are the same as the initial setup would be. So the parameters here, there's no changes at all. The 3 same parameters gets used. Again, we don't need to keep track of the date, because structured streaming help us keep track of what file or rows of records we've been processed. In the next command here, we are doing the setup again for this data set. For us, this changes a little bit here, where when we're organizing our data in the silver layer, we organize it by business domain and then the data sets. Okay, so that's why you see this is the production. This is the production business units that we have at our company, and then this is the data set name that we're using. Any processing that we're doing past bronze will be we'll be using the table name instead of using the storage location name. So that's why you see for bronze, we'll be using, when we're accessing the bronze, we'll be using the table name instead. And then in gold, in the next notebook, when we're accessing the silver, we'll be also be using the silver table name. We're going to specify the storage location and as well as the checkpoint for the file that we're writing to. In this case, it's the silver, and then we're compiling the table name again, the same thing that we did in bronze. Okay. Now the next difference part here is we need to define our structure for the silver data, where in bronze, we're using the implied schema, but in silver, we define that schema. And this is important because we want to make sure if there's any issues with the schema as the data being loaded, we catch it right away. We don't want data that are non-conforming or non-check is getting into our silver layer, as the data is supposed to be clean at this layer. Okay, so again, in command 6, we just did a quick basically select statement on the bronze table just to see what it looks like. It's exactly the same as what you saw a second ago when we looked at the previous notebook. And in command 7, the next 3 blocks of code, it's going to be very different than how the batch code was laid out in the previous sessions. So we're going to define a function, a data quality function that takes in a batch data frame. And this check here is exactly the same, pretty much a copy and paste of what the batch code does. It checks to make sure this data doesn't have any rescue data. If there's rescue data, as we talked about, then we know this data is has issues reading into the proper fields, and we don't want that. And then we also have a business rule that says that the kilowatts on each of the reading must be between 5 and 20. That's just the amount of load you can have on the machine on each of the meter machines. So if this reading is above 20 or below 5, we have an inaccurate reading, so we'll be removing that as well. And then finally, we want to make sure that the measurement date is a timestamp. So this is just a check saying that we're going to cast the measurement date into a timestamp into a _TS column, measurement date _TS. And if this column becomes if it's we only want the non column of this, and then anything that are null we do not want, because then that means the conversion has failed. And then we're just going to drop the column after we complete that check. So with that, if we run this when the time a batch is being passed into here, then we can tell which data set has been has error or versus the clean data set. So in here we're compiling the clean data, and we're returning both the clean data and the batch of data that have issues. And it's up to us to deal with how we want to deal with the error data, which we will talk about in 2 functions time, I believe. So the next block of code talks about deduplication. So it is very possible that our data has duplicates information in it. Could be a system error, could be equipment error, could be system delay, could be many different reasons why we're getting duplicate data. So we know that for each of the measurement for a meter ID, the data, the power that they're providing to the zip code in the state that we're in, there should be one of those records. So this code basically is saying that if I have more than one of those findings, then I must have a duplicate, and I want the newest file, which is basically the input file modification data we have, and we sort it by descending order. So the newest file, the newest files are measurement kilowatts, okay? And all the old ones essentially get thrown away, which is what the next line does. Is basically, given this window grouping or the group by, I only want the first row. and I throw the rest of them away. And I'm going to return this this data frame as well. Okay. Now, with both of those in place, we are going. The last things we're gonna do, the last function that we're gonna create is to fix our schema. As we talked about, the measurement date should be a timestamp. We want to cast a kilowatts into a decimal type, as that works best in data warehousing. And then we're going to either rename or drop some of the columns that we no longer need to keep track of in Silver. Okay, so with those three custom functions that we built, we need to compile them together into one last function called custom process. Remember, in the PowerPoint diagram, we talked about the conveyor belt system has a custom process. So we define a custom process with the batch that's coming in, the micro batch, the small packages of data coming in as a data frame, and then we take in a batch ID as a parameter. So those two parameter, it's standard. It must exist in this function, as they are mandatory for this function to work. So yeah, as we talked about, all this function really does is call the data quality, check the deduplications, and fix our schema. That's all this function really does. Now, I do some print output here. For our demo purposes, it might be better to write out the air data frame into a different storage location that you can troubleshoot later on. But for demo purposes, I didn't do that. I just print out the count. But you can feel free to do that, and you can do the same thing as what you see in the next block of code here, which is basically I'm calling using the delta table merge function to merge the data into the existing silver table that we created from 5 blocks above. Okay. So this is the same code that we would have in the batch processing, and basically what this is saying is if the measurement data I have with the data is the same as the matches from the micro batch data frame that I have, compare with the silver table. Sorry, this is the target is the silver table. Source is the data to silver, the new data. If the measurement date, the meter ID, and the zip code is the same, then that means either I have a data correction, and if I have a data correction, my record must be newer than the original record set, and then I'm going to set this data in. If not, if this record it's a new record essentially, if this condition is not true, then I want to just insert everything that is doesn't match the condition that I specify above. Okay, so now again, for demo purposes only, I want my structure streaming to read 10 files at a time. Again, this could have been in bytes that we talked about a second ago, or in the previous bronze document, which is probably a better approach to do. And we are reading the table in bronze, as we talked about. So at this point, we'll take the bronze data stream, we'll write it out as a stream into silver. Again, we have the available now, we have the checkpoint location. We're merging schema, but there should be no schema change as we specify the schema in both cases. But what we actually do here is a new command that we call is for each batch, we'll call that custom process that we specify in 2 functions ago that will go through all of this check for us. And we'll also define the query name. So just in case if we ever need to go through the log and do debugging purposes, we can see this is the name that you would have gave. So the output of this is essentially contains the output of this print statement here. Basically, it's saying that I have 3 batches of data, and each one has the record counts of the clean data I have, and I don't have any data quality issue in this case. And then everything below here is pretty much just the same thing as we talked about earlier. I'm going to run my vacuum and optimize. If I haven't ran any vacuum in 30 days, I want to run that and clean things up. And then here's a look at what the silver data looks like in our pipeline now. Okay, and yeah, those are just more code that for us to see. So I pick a meter ID on a specific day and a zip code, and there should be no duplicates, right? So it just generated one. In this case, it selected the one return one record, which is what we expect. Okay. Now, finally, we go into the gold. We'll quickly dive through this one really quickly, as everything is pretty much recovered 99% of all the streaming functionality that we discuss. In gold, in the medallion architecture, we store the data based on business domain. In this case, again, the business domain is production. No surprise there. We did that in silver. For reporting purposes, our data set name is a fact table. We went in a little more in depth in the batch processing in the third session, talking about what is a DIM and what is a fact table. So please, if please go take a look at that recording. It will help you understand what is the difference between a DIM and a fact table versus the table that we read this data in through the JSON file. Okay. Other than that, there's no differences here other than data, the catalog, we're storing it into the goal instead of otherwise. In order for a table structure to change into a dim and fact, we need to join this data with other data. So in this case, dim dates, dim time, we have a dim power meter and a dim service location. So those are the tables we'll be joining in order to get the surrogate ID or the SID of those, or like a kind of similar to like a primary key of those field. So we don't actually keep tracks of the actual value in those or duplicate value in the fact table itself. So you can see in here the structure compared to silver, right? This is the actual dates. This is a ID of the meter. This is the zip code and so forth. But in gold, those are all they're all similar to like a foreign key in this case. If you have a database background there, pretty much is it's a generated ID that we use for storing this information. So we only have one service ID that keep tracks of let's say this zip code here, right? So yeah, so with that, I'm just gonna click run on that. I think I haven't done that so already. Again, we're doing the same thing here. We take a look at the silver table for you guys to see what the data looks like. And in command 8 here, all we're really doing is just selecting the data that we need. So we know that in order for me to convert my datetime into the dim and fact structure, the calendar day is what matches this 2013 January 1st, and then I want to use the ID instead of using the calendar date. So I'm just grabbing those two specific column. I'm just renaming it for convenience purposes as we do the joint. So we have unique names that we can work with. And then command line here again. This is same story. We create a new function in order to contain all of our logic in terms of how the data, the micro batch data coming in needs to map to the to all the dim tables that we have. This is exactly the same logic that we had in our batch processing. we just put it into a function instead of leaving it in a procedural form. Okay. So after all the data is joined, we'll do append a few more metadata information in there. More specifically, key hash and value hash. Again, this is part of the dimensional modeling structure where you take your key and do a SHA 256 on it, and this is going to be used for your comparisons. You do the same thing for your value. We'll talk about a little more about why we're doing that instead of comparing each of the column in a quick 2 moments there in the next block. We're doing a quick rename. We want to call it power consumed kilowatts instead of measurement in kilowatts, and a few metadata information that we put into every single one of our pipelines. Right. So no surprise here. The next function that we have is the custom process. So in here, the reason why we use a key hash versus using the individual column is really enable us to do a better code reuse, because this code here essentially, at least the compare part of the code, that never has to change. There's always going to be a key hash regardless if you're on the new data coming in or on the target side. So there's only one column the Databricks or Spark needs to compare, and it makes it a lot more efficient of a code comparison than trying to grab all the individual data fields to compare them. So pretty much in here, if our keys, our 3 fields that we've been talking about are the same, and if the value doesn't match, then clearly, the value has changed. So we're just going to do an update on those. And if we don't find this key hash, right, if it doesn't exist, then this must be a new record, right? So just pretty much like a primary key comparison, if you think about it that way. Okay. And since we already created a table, if your table is not found, we want to throw an exception saying that, hey, my table is not there. What is going on? Okay. So same thing that you saw earlier. We use the for each batch custom process. We defined a query name, right? Same as before. Now in this case, I only have one batch that I need to process. It was able to process all 51, almost 52,000 records within one batch without any problem. So you don't always have to slice it down into smaller, but you can at your disposal. Okay, and now the bottom part of the code here is pretty much the same, as we're just trying to clean up or showing you some of the data output that we have. So I won't be going through this particular code, but this is the code that will be included into my GitHub repo in a few days. I'll be pushing out the data, but this basically has all the tables that it gets generated, including the tables, the 3 tables that we just went through into building. So this is just a quick select statement using the Databricks SQL in the batch processing. This is a new feature actually in here. We did the same thing in batch processing to run a similar query, but this is now serverless, so we don't have to set up our own warehouse instance. It automatically can spin something up quickly for us. So this kind of shows, the result, and I quickly just drew a map here that shows all the power usage that we have. Okay. Now, how do we run this normally, right? Now, you're seeing this is being ran manually through all the pipelines. So that's not going to be very useful for you, right? So As well, in order for this to be able to schedule and run, I created Azure Data Factory pipelines for the demo as well. And this is pretty much the same as what you saw in the batch, so I won't go over them in depth. But one thing to note is really I ran pretty much the three pipeline here before the demo today, the sessions. And then when you're running this, make sure you turn the last item into active. So I pretty much just skip over this and ran the three pipeline manually as part of the demo. So if you want to completely automate this pipeline, set up a trigger, having this ran every, let's say every hour or every couple of hours. You just have to enable the last pipeline here, and then everything will work. So there's about, I want to say about 7 or 8 tables in total that we have. We have a dim dates, dim time. This is the power consumption pipeline that we just witnessed a second ago. And then there's the power meter that generates some of the reference data that we need, and then there's the zip code information that we have as well. So all of that is all coded. There's a master pipeline that you can run as soon as you turn this back to turn to active, and then you can go ahead and run that pipeline. Okay. So with that takes us to the Delta Live table. So the reason I want to mention the Delta Live table, as this is one of the newer feature that Databricks has created. And the benefit of the Delta Live table, it utilizes what they call a declarative framework. So a declarative framework is very similar to how SQL works. You tell SQL, I want to grab the data between 5 to 10. That's essentially a declarative functionality. You tell the code what you want to get done, not how, essentially. And Delta Live Table supports Databricks SQL and Python. Now, with that capability, essentially, it allows your Databricks SQL to use autoloader that we talked about in the first demo as well, which is very powerful, as previously that required you to know either Python or Scala to run. And finally, what I feel like is the most important, most beneficial thing is a built-in simplify data quality by having this capability to define what kind of data quality checks we need directly in when we create the SQL or the Python code. So for our second demo here, we will build a bronze and a silver table, basically what you saw in the first demo, but using Delta Live table. Okay. Right. Swap over to that. So in Delta Live table works very different than the Spark code you saw. First thing you note, this is a SQL. So I wrote, you guys have seen quite a bit of PySpark. If you guys want to learn more about Delta Live table using PySpark, please, do look that up. I did my demo mostly focusing in SQL because that's totally different than what we have seen so far in any demos that I have presented in the series. And I think it really highlights the elegance of how Delta Live table really works. So in our case, we won't be defining any parameters here. Parameters are defined as a configuration inside our Databricks workflow, which we'll touch on after we go over this file. But pretty much we will still be using the data lake name as one of the parameter or configuration that we have. And this is the same value that we've been using. This is our demo data lake that we have. So the next thing we do here, as we talked about earlier, in the bronze layer, we really are just reading the file in and appending the file into bronze. We're not going to be doing any data checks. We're just going to merge the data or append the data in directly. So, all that code is simplified to, about 10 lines of code here. Basically, this says we're going to create or refresh this live table, which is a different name that we gave. I left the comments in there. This is optional, but good practice. And then all I'm doing is I'm saying I want to select all the data that I have in the JSON, right? You saw this code to get the input file name by going through the metadata and using the metadata to get the file modification time, which I'm giving a different name. And then we're calling the cloud file, which is exactly what you saw before, passing in the path, which is what that we set up as well. We're going to tell it this is a JSON file, and then we kept the same parameter that we talked about earlier in the demo. This is going to be max trigger file 75. Again, use the number of bytes instead in a proper development environment, and then we're going to be inferring the column type. Now, as you can see here, I'm not running any cluster because you're not going to be able to run a Delta Live table directly through a notebook. It has to go through a workflow. So here we're just defining everything and declaring everything, and then we'll go into the notebook to look at the process there. Okay. Again, we have a whole notebook for the silver code, and pretty much we've broken the silver into 3 commands. So the first one here is applying the data quality check, right? Make sure the rescue data is null. We go to, if the rescue data is it is not null, then this constraint basically says that if I expect this data to be null, if it's not, I want you to remove it. I want you to drop it, right? And you're going to do the same thing for the 5 to 20 measurement reading, as well as the measurement date, the timestamp. So you want to make sure the measurement date is not null, right? Not null check in here. So and then if all of that everything is good, you want to select that data that meet the standard, and then you will drop any of the columns that or rows that you don't need. And then the source of this table, this data quality table, it's based on the stream of the bronze table that you created above. As you can see here, it's prefixed with live, and that's how we know this is a Delta Live table. Okay. Now, this is all great, but it didn't do any duplication for us, and we do need to do that. And Databricks recommend we do that in 2 separate steps. The first one just for the data quality, and then the second one we will create an incremental live table. And essentially, this is a table that gets incrementally loaded as part of as the data is streaming into the live table, and it's supposed to be meant for low latency result. And how do we get data into this table? Like, this table doesn't have any schema definition, doesn't have any columns and rows getting defined, right? So, and this is done by using apply changes into. So we're going to apply changes. We're going to put the data in this silver table, again, coming from the live schema of the data quality table, the DQ suffix there. And the key the unique identifier I have. Remember, we talked about the three columns that are unique. That's the measurement date, meter ID, and zip code. So those are the key. And I want to order this data based on the input file modification date. So, and that's how you would sort the data, um, uh, in by letting the system know what each of the sequence of the data is, right? So they can tell what data is new, what data is old, if the same key appears. Now, finally, you get to choose which column you want to go into this silver table. So for me, I want to choose all the column except for um, the metadata column that I don't need anymore. So in this case, it's the rescue data, the input file, and then the modification dates, because all of that has been now processed into the silver layer. Okay. Now with that, we will jump into the workflow and see how that we need to set up the pipeline to run. Because like I said, we cannot run that notebook on its own. So in Databricks, you can go into the workflow, and then there's a Delta Live table workflow here that you can define. And the tricky thing is when you define a pipeline, this pipeline, it's what's responsible for your live table that you create. When you delete this pipeline or the workflow, it also deletes the data in the pipeline as well. So just be mindful about that. This is called manage table process. Okay. So and which is why I'm going into one that's already set up, because if I delete this, then it's going to be a little bit difficult to show you guys the steps here. So for me, you give it a name. I always prefer my pipeline to start with PL underscore, just my naming convention. You can call it differently if you like. For me, I want this pipeline to be triggered instead of being continuously ran, right? As we do micro batching, similar to micro batching, you want to control when the pipeline gets ran and not have it run all the time. We select the file that you have with one file that defines both the bronze and the silver. For my destination, I elected to use Unity Catalog, which is, this whole environment uses that. And then I store this data under the DLT dev schema. And for me, this is a very light work, so I'm just going to set up one worker, fixed size. And then last but not least, this is the Delta Lake name that the data lake name that we specified earlier. Now, you can also provide a pipeline ID. I didn't do that, but that's you can do that as well if we want to do that. So we're going to save. And normally when you save, you will see this screen. Of course, your data won't be processed originally in here. So you can either click start, you have a new data coming in, or in my case, for the demo purposes, I'm going to refresh, do a full refresh. So that means any data that I have been read will be discarded, and then they will reprocess everything from scratch. Okay. So that's basically telling you that we will recompute everything. So this will take a little while to run, probably 3 to 4 minutes to run, as they need to acquire a different type of virtual machine or compute to run this process, as it's very unique and optimized by Databricks. So yeah, we'll give it a wait while we jump back to the presentation to just do kind of a summary of what's taking place while that's running. Okay. So a quick kind of summary here. So today we learned that using structure streaming enables us to process our code using smaller batches, or what we call micro batches. And this makes our code more scalable and more efficient, as we don't want a cluster to group bigger and bigger and read in order to compensate for the data that's coming in. With the autoloader, you can detect new file that's available from our landing storage, and this allows us to use structured streaming, sorry, that typo there, for processing. And you'll be able to track all the which file has been processed or which role record has been processed as well through structured streaming. We can define with the Delta Live table, we can define the data quality and the business rule that we have through declarative the framework, which is basically your case you saw that in do main of it in SQL, but you can also do that in Python. So that definitely simplifies our code dramatically and improves our development productivity. As I said on the call earlier, all the code will be available in my GitHub repo under demo slash Databricks slash for building a streaming solution. This code will be up in the next few days, as I have not had a chance to upload this data into the environment, as we're still kind of waiting for the process, I guess. Okay, so before we jump to the Q&A, I just want to thank you everyone for attending this 4-part series. As I alluded in this presentation, there's a lot of synergies between this presentation to the third one and so forth to the beginning of the series. So I strongly encourage you to watch the series if you haven't had a chance to do so. And the topic we discuss here includes creating learning how Databricks work, building a batch pipeline to building a lakehouse using medallion architecture, and we finally landed here today with structured streaming and Delta Live tables. So yeah, please go watch the other parts of the video. If any of the concept I glossed over here today that got you confused, as they were covered more in depth previously. All right. Hey, actually, we're getting some results here after that. This is a perfect timing here. So as you can see, there's a lot of stuff that went on in the past, 6 minutes or so. But here it tells you for each item, the number of record that has been processed. So in this case, the latest run of this data. So you can see all the runs that I have. The latest run, it completes in 19 seconds after the compute is available. You roll 52K to record, which is right, because we have 51 and change thousand records, as we saw throughout the demo. And we can see here that we can see the data quality that we have. Again, bronze, we don't expect any data quality issues. So everything was written, 51,840 rows. And we can even see the schema that, again, it's a string for the dates. That exactly what we saw in our structured streaming demo number 1. Now, going into silver, again, this, is pretty quick as well, 4 seconds, same number of rows. Now, our data quality checks that we define actually shows up here, right? Do we have any error records? Is the reading between the certain number, is the measurement date a timestamp? So you can tell if anything is failed, you can see it right away here. Again, number of written, number of schema is dropped. And also how, look at our schema that has changed, right? Like we have measurement dates here now, which is in a timestamp where it wasn't before. And I think the most fascinating thing for me is in this incremental table, it took 10 seconds to run, but it's not tracking any record because it just updates it, right? It's a quick update of the data, so they don't really track of any changes of this data, as it just applies the changes directly onto the table itself. So you can think of it more like almost like a materialized view in a lot of way, right? So yeah, the schema, we removed some of the columns. We didn't do any data quality checks here, so nothing was dropped, and it was completed as well. So you can also look into each of the logging item here, and it will tell you more information if something failed. So this is the way to debug this. For example, If they had an issue, you can click on the summary, and the summary will tell you what the error is. You can jump into the JSON. It will tell you more in depth what that error message is. In our case, there's no error messages, which won't be able to highlight that very easily. Okay.